Finding the product of prime factors. Remember, a prime number is a number which can only be divided by itself and the number 1. In other words, a prime factor has only two factors, itself and the number 1. Now the number 1 itself has only got one factor, 1, so it is not prime. The number 2 has two factors, itself, 2, and the number 1, so it is prime. The next prime number would be 3, then 5, then 7, etc. What they want you to do here is they'll give you a composite number, quite a large one, let's say 84, and the question will be, you have to find the prime factors of 84 and then write them or express them as a product. Product means times. So your answer will be a list of prime factors that when you multiply them together, you will get the answer 84. Right, there are two methods of displaying this. There's the tree method and there's the table method. They're just different diagrams of expressing your answer. I'm going to start with the tree diagram. Right, what you do is you start with your composite number that they're asking you to find the prime factors of, and you draw two branches underneath. Now, I always teach that it's best to keep your prime factor to the same side, the left-hand side, and the partner to the prime factor that multiplies to give you 84 on the right-hand side. Now, 84 we can see is even. That means it must be divisible by 2, and 2 is a prime factor. So I'm going to put that on my left-hand side. And then you have to find the partner. 2 times what is 84? 2 times 42 is 84. Okay, next step. We look at the right-hand composite number and we decide what prime factor does 42 have. Well, we can see it's even again, so it must have a factor of 2, which goes on the left-hand side, and its partner, 2 times what is 42? 21 is the partner, goes on the right. Then we look at the composite number on the right, and we say what prime factor does 21 have? In other words, which prime number will go into 21? Well, I can actually think of two numbers. The number 3 goes into 21 and the number 7 goes into 21, and they're both prime. It's up to you, you just have to choose one or other of them, because this is really us finishing it. I'm going to choose the smallest, the 3, and put it on the left hand side, and the 7 is its partner. And we're really finished now because we've ended with a prime number on the right hand side, but I teach to just do the final step where you'll have 1 on the right hand side and 7 on the left, because 7 has factors 7 and 1, and 7 is prime. I do this because at the end I just want you to take all the left hand numbers, which are all the prime factors, and that's your answer. But they want it as a product, so you have to express it with times sign. So the answer is 2 times 2 times 3 times 7. And if you want to check that's right, then multiply them. 2 times 2 is 4, 4 times 3 is 12, and 12 times 7 is 84. Therefore, this is correct. A shorter way of writing this is to say 2 squared, or 2 to the power 2, times 3 times 7. These are both the same, they're both correct. Now I'm going to show you how to do the same, but shown as a diagram, table diagram. So this time we draw a line, like that, and we put the 84 on the right hand side. And then I'm going to draw these. Okay, now we do exactly the same as the last time, and we say, okay, what's a prime factor of 84? It's even, so my prime factor goes on the left hand side. Prime factor is 2. Its partner, 2 times what is 84? 2 times 42. Then we look at the right hand side. What's a prime factor of 42? It's even, so 2 will be. And its partner to make 42, 2 times 21. Then I look at my composite number. What's a prime factor of 21? Well, a 3 is. I'm going to put my 3 here. And its partner is 7. What's a prime factor of 7? Well, 7 is prime, so 7 and its partner is 1. And when we get to the 1, we know we're finished. And the answer will be all the numbers on the left-hand side, the prime factors, which we are going to write as a product, 2 times 2 times 3 times 7, or 2 to the power 2, 2 squared, times 3 times 7. Okay, let's give one more example showing both. And this time we're going to use the number 252. I'm going to do it's a tree at this side and a table at this. Okay, we can see that 252 is even, so it will have a prime factor of 2. That goes on the left-hand side, the left-hand side. The partner to 2 is 2 times what is 252? The partner is 126, which we write on the right-hand side. And then we say, okay, what's the prime factor of 126? It's even. So I know for my branches, I can have the prime factor 2. 2 times what is 126? 2 times 63 is 126. We look at the right hand side. What's a prime factor of 63? Well, I can think of 7, because 7 goes into 63, and 3 goes into 63. As a rule, I use the smallest one. So it doesn't matter though which you choose, but I'm going to choose the smallest one, which is 3. And 3 times what is 63? 3 times 21. Okay, now we look at the right hand side, the composite number, and what factor of 21 could be prime? Which prime number goes into 21? Well, 3 does again, and its partner is 7. 7 is prime, so we could stop here, but I just like you to stop at the number 1. So, what prime factor goes into 7? 7 and its partner is 1. 7 and its partner is 1. When you get to 1 on the right hand side, you know you've finished. So the answer is all your prime factors on the left. All the prime factors on the left. But they want it as a product. So that means times. You write them with a times sign in between. So the answer is 2 times 2 times 3 times 3 times 7. And to check it's correct, 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. 36 times 7 is 252. So you know you're right. And for those of you who like to write your indices or exponents, that's the same as 2 to the power 2, because there's 2 of them, times 3 to the power 2, or 3 squared, times 7. These two answers are the same. They are both correct. And that's how you do it.